All right, so here we are on the next page of the notes, and what we're going to start off with here is just a quick reminder of when you have inequalities and you're solving an inequality problem. Much like solving equations, you are allowed to add and subtract numbers as long as you do it from both sides of the inequality. So think of the inequality like an equal sign, all right, and you're allowed to add and subtract numbers as long as you do it from both sides. What we want to point out here, though, is that when it comes to addition and subtraction, you don't have to worry. The inequality will never change, right? If you started out with a less than, add and subtract anything you want to, it'll stay less than. If you start out with greater than, you can add or subtract anything you want to as long as you do it on both sides. It will always stay greater than. Nothing will change the sign of the, or will change the direction of the inequality with addition and subtraction. So we'll go ahead and try one of these. I think I got a problem here at the bottom of the page, so let's scroll up a little bit. And let's go ahead and give it a shot with this example problem. I'm going to want you to solve for y. What I've told you is y minus 6 is less than 3. What we're going to do is get this y all by itself, and since it's a plus 6, I'm going to need to subtract 6 from both sides. Now, what the property above tells me, let me subtract 6 from both sides, or I'm sorry, add 6 to both sides. What this property up here above tells me is that when I do addition, right, I can add any number I want to both sides of the inequality. It doesn't change the inequality. So I'm still down here going to have y is less than. Those 6's are going to cancel each other out, and now I will have 3 plus 6, which of course is 9. Y is less than 9. Now that's my first way of writing the solution, but I have two more ways. Let's go ahead and practice those. The second way of writing the solution is set builder notation. Remember, this is going to be with the one with the braces on each end. So let me go ahead and throw my first brace. Oh, wow, that did not turn out right. There we go. There we go. So there's my brace, and then I need to tell you what the variable is. In this case, my variable is y. So it's going to be all y's. Remember, the bar means such that, and then I rewrite my inequality. All values of y such that y is less than 9, close the braces. Now I know that this might seem like, what's the difference between this one and this one? You're right. There's not much difference. I think they're very similar as well. But when it comes to the standardized test, ACT, SAT, they like to write it in set builder notation as opposed to inequality notation. And I don't want you, after you get done taking this course, to begin studying for those tests or go take those tests and be like, I have no idea what this is. Why didn't he talk about it? I just want to make sure that you are aware of what it is that they like to use it. They'll use this much more often than they'll use this. So it's good to just get practice with it so that you're familiar with it. Finally, the third one is to do a number line, which we can go ahead and do. Let's draw a number line in here. Now, I got to go all the way to 9. It's got to be everything less than 9. So let's go backwards here. I'll do 11, 10, 9, 8, 7, 6, 5, skip a few, 0, -1, that's plenty. Here we go, I'll do it in red. It is strictly less than. Does that mean open or closed circle? Right, I'm going to need an open circle. 9 is not included. It is only everything less than 9. So we will then go ahead and shade my number line. Everything less than 9, not including 9. So that's going to be everything in this direction going that way. So there we go. All three solutions, inequality, set builder notation, and doing it on a number line. We'll do that for all the problems. That's it for everything on this page. Head on over to the next page. We'll try a few more. I'll see you there.